Hello, 7th graders. This lesson is Probability Part 2. Last Friday, you did some activities with your table group in class that was kind of an introduction to probability, where you were either flipping 2 coins or rolling a letter dice or a number dice or using a virtual spinner to calculate some probabilities. And this lesson goes a little bit deeper into some concepts related to probability and is a preview for an activity that you'll be doing in class later today. So remember that probability basically means the chances or the likelihood of something happening. And probability, I always like to start by writing it as a fraction. I think that's easiest. So it's always what you want to have happen on the top as the numerator, and then the denominator is the total number of outcomes that could happen. So here's an example. On a regular 6-sided dice, what is the probability of rolling a 4? And remember that this is the notation for probability. So the P stands for probability, and then whatever's in parentheses is the outcome that you're looking for. So the probability of rolling a 4. So on a regular 6-sided dice, remember that only one side has a 4 on it. That's what we want to have happen. We want it to land on that one side. And then the total number of outcomes is 6 because there's 6 sides total. So as a fraction, that would be 1/6. Now as a decimal, you already know how to convert fractions to decimals. You do the numerator divided by the denominator. So if we do 1 divided by 6, we get 0.16 repeating. And you also already know how to turn decimals into percents. So we're going to either multiply this decimal by 100 or just move the decimal point over twice. And that would give us 16.6 repeating percent. Remember, if it's repeating, just put the repeatant bar on the top. Don't truncate it and don't round it. Just put repeating. All right, you will also remember that all probabilities range from 0 to 1. So 0 are things that are impossible. They are never going to happen, okay? So an example of that with the dice is the probability of rolling a 7 is never going to happen on a regular 6-sided dice because a 7 is not an option on a regular 6-sided dice. It only goes from 1 to 6, okay? And then on the other end of the spectrum related to dice, if something is certain, it has a probability of 1. So on a dice, the probability of getting a number 1 through 6 will happen every single time because those are your options, 1 through 6. So we go from impossible to certain with varying degrees of probability in between. Okay, so right in the middle is 0.5. We say that's an even chance or a 50-50 chance, or something would be as likely as unlikely to happen. And you're going to see that word, that phrase, later while you're working on your activity today during class, as likely as unlikely. That means it's 50-50, okay? It's going to happen half of the time, okay? Anything below that is unlikely, okay? Ranging from 0 to 0.5, unlikely to happen, okay? From 0.5 up to 1 is likely going to happen. So you're looking at this range, okay? If it's less than half, it's unlikely. If it's more than half, it's likely, okay? So keep those words in mind later when you're working on the activity. Impossible, unlikely, as likely as unlikely, likely, or certain. Okay, there are a couple of situations that you will see today where you will need to use something called the counting principle. And the counting principle helps you find the total number of outcomes for a scenario, okay? And it gives you a quicker way to do this. Since the order most likely does not matter for these types of problems, you can multiply the total outcomes for each individual event together, and that will give you the total number of outcomes for the situation. So I think it's easiest if we can look at an example of this. I'm going to try to hide the little webcam shot over here, and let's see if this works. So, for example, for lunch, you can have 2 choices of entree, let's say either a taco or a burger, 2 choices of sides, either salad or soup, and 3 choices of dessert, ice cream, cake, or pie. How many different combinations of lunch items can you create? Okay, so most people, when they're thinking about this, might make a diagram like this, okay? And they're going to think through all their options. So let's say I get a taco. with my taco, I could get salad or soup. If I get a taco and salad, then I could get these 3 dessert options, ice cream, cake, or pie. So that already is 3 different choices. Taco, salad, ice cream, that's 1. Taco, salad, cake, that's 2. Taco, salad, pie, that's 3. So you can count just these 3 examples down here, and that tells you 3 options total. Okay, now I could also get taco, soup, and ice cream. That's a 4th option. Okay, taco, soup, cake, that's the 5th one, and then taco, soup, pie, that's the 6th one. Okay, so just on this half of the diagram, we already have 6 options. Now we can replicate that over here. If you get a burger for the entree, you would have another 6 options. So that's 12 altogether. But that takes a little bit of thought and a little bit of diagramming to map all that out. So if you use the counting principle, it's going to be a lot less work and a lot easier to be sure that you haven't missed anything. Okay, when you're making a diagram like this, it's going to be very easy to miss something. So what the counting principle tells us that we can do is multiply. So we have entrees, we have sides, and we have desserts. So if we use the counting principle, 2 entree options times 2 side options times 3 dessert options. 2 times 2 is 4, 4 times 3 is 12. That would give us 12 combinations total. And just by multiplying those, we didn't have to make the diagram, we didn't have to think of all the different options and then worry about if we missed one. You're just multiplying the choices for each thing and then getting your answer. So 2 entrees times 2 sides times 3 desserts is 12 total. All right, so there is another type of situation in probability where the order does matter, and this is a case where you will have to write out the different combinations, okay? So, for example, Pam has homework in French, social studies, and math. She's trying to decide in what order she should do her assignments. How many orders are there for her to choose from? Okay, so you actually need to write out the options for this, the different combinations, okay? And this is what it might look like. French, social studies, math. That's one order that she could do things in, okay? You could also do French, math, and then science. So just flipping around the other 2, the last 2, okay? Another combination would be if she started with social studies and then did French or math, or she could do social studies, math, and then French. And then here's the last 2, math, French, social studies, math, social studies, French. So once you see that you have all the different combinations, that would be 6 different orders of doing her homework total. So 1, 2, 3, 4, 5, 6. 6 things total. So when you're writing out these combinations, make sure you have some type of order to what you're doing. So in this first line, I had French be the first assignment both times and just flipped the order for the other 2. And then I did social studies next. I just kept it in the same order, French and then social studies, and flipped the other 2 assignments around. And then my third row was starting with math and then alternating French and social studies. So try to have some kind of order to what you're doing so you can be sure not to miss one, okay? Now, there's not a way to use the counting principle for this because she just has 3 choices, okay? We cannot multiply 3 times anything because there's nothing else to pick from. She's just picking the order of her homework. So unfortunately, you do have to write out all the different combinations for this to see how many there are total. All right, that is the end of our slideshow for today, and I will be posting this on Schoology for you to see while you're working on your assignment today during class. Thank you.